In today's OpenGL demo, I'm showing off how I made Breakout in C++. So as you can see here, we have this menu screen with press enter to start and type 1, 2, 3, or 4 to select a level. So let's go with level 4 and push enter. So we can move around the paddle on the bottom using A or D, and when we push space, it will launch the ball. Like this. And if you get all the blocks knocked out, you'll get a win screen, or if you die 3 or more times when the ball goes below the paddle, then you lose the game. And I've lost 2 lives, but if I just demonstrate losing a last life, that's the main screen. So the way this works is we have a game file class, a ball class, then we have our game object class, and then a few others that we'll cover as we talk about these 3. So the game class, it stores all of the information about our game. For right now, we'll talk about the collision detection and the win or lose states. So we have, for our collisions, we have check collision and with 2 game objects and a check collision with a ball object and a game object. A game object is simply has a position, size, velocity, color, rotation, and then if it's a block, it can be is solid or destroyed. And then a ball is built from a game object and it has a radius and a stuck value. So if we're checking 2 game objects, we simply calculate 2 bools of collision x and collision y, which is we take the position plus the size of the first object, and if it's less than the second object's position, and if vice versa, the second position's plus the second's color is less than or greater than the first's position. So what this basically does is if on the x-axis, if they're touching, this will be true. And we do the same thing for the y-axis, and then we return, this is our collision. We have a, where is it? We have a namespace for in game HP. We say type dev std tuple bool direction vec2 as a collision. So here we return the collision, and we say if these 2 combined are true, that's what we return. If it is, we say up and with no velocity. Then the other one, it's a little more complicated, but we get a center of the ball's position, and then we get the game object's half value and center value. We get the difference between the center and the half and the game object center, and then we clamp the values and we get which one's closest, and then we do the difference between closest and center. And if that's less than the radius, it means the circle's touching the square, and we return true, which direction it hit, and the difference. Otherwise, we return false. And the way we get direction is we have this array of called compass with 4 directions, and in each of these we basically just check, is this the closest direction, and if it is, we set it to best match, and then we return best match. And then what we do with these values is in our update function, which we call every frame, we run this do collisions function, and what this one will check is for each box in the level, if the box is not destroyed, we check if it's collided with the ball, and if it has, we destroy it, we play a sound, and we increase the speed, which is something I didn't show off earlier, but if we just enter and start it, the ball progressively picks up more and more speed until you die, and then it resets. So as you can see here, it gets 2.5% faster every time it destroys a block. As you can see, there, slowed. And then we get the direction and the direction velocity, and then we simply apply this to the ball here. If the ball is not stuck, we check collisions with the paddle. And then for our ball, we simply have a radius and a stuck value, and we have this function move, where if it's not stuck, then we add the velocity times delta times speed. And then this code allows it to bounce off the sides of our screen. And then the game object is fairly simple. It's just a bunch of values and we can render it. And then we have all of the screens. So we have 3 states. We have a win state, a game state, and a menu state. So in here, if we go to our rendering code, if the state is game active or game menu, we draw the level. If it's game active, we show our lives. Otherwise, if it's the menu state, we show press enter to start and the controls for switching levels. And then we render the background no matter what. And if it's game win, we print you win and type enter to play again. And if you want to see how we set up the rest of Breakout, you should check out this video here where we explain how we set up the levels, how we load levels, and how we do bricks. And until next time, see ya.